Hello class! Today we're going to review graphing logarithmic functions. I wanted us to start by looking at the kind of general shape that we can expect to see with these sort of functions. Starting with our parent function y equals log of x, you can see that the graph makes a sort of curve that kind of goes in a positive slope direction. So as my x is increasing, my y is increasing as well. However, when we look at y equals negative log of x, now we have a sort of negative slope situation. So as my x increases here, my y is now going to decrease. So keep this in mind and look for some other patterns as we work through these examples. It'll make identifying the graphs a lot easier for you. Let's start with our first example. So we have y equals log of x, our parent function, being compared to y equals log of x minus 2 plus 3. So let's first start with our parent function. I'm going to plug that into my calculator so I can get a table of values that I can then plot on my graph. When you turn on your calculator, you're going to go to y equals, go ahead and plug in your equation, log of x, close parentheses. And you can look at the graph, but we're looking for values, so press second graph. And we're going to go to this first number where we see the error. That's where our vertical asymptote will be. Our points are at 1, 0, and the next whole number's at 10, 1. So your graph should look similar to this. I've got my vertical asymptote at x equals 0. So my graph is going to get closer and closer to x equals 0, but never quite touch it. I have my first point at 1, 0, and my second point at 10, 1. So now let's plug in our second function into our calculators so we can get some points, and go ahead and plot that and compare the two. I'm back in y equals in my calculator. I'm going to type in my new function, log of x minus 2, close parentheses, plus 3. Press second graph, and we're looking for that first point where we see the error. So our vertical asymptote is at x equals 2. And then I have a point at 3, 3, and I can go all the way down for my next point at 12, 4, and that should be enough for this particular graph. Your graph should now look something like this. I had a vertical asymptote at x equals 2, so this line is going to get closer and closer to x equals 2, but never quite touch it. My first point was at 3, 3, and my second point was at 12, 4. So it seems like we shifted to the right 1, 2 places, and up 1, 2, 3 spaces. So when I was recording this, I completely forgot to discuss the domain and range. If we're looking at our first function, which I graphed in pink, the log of x, the domain, when we're thinking of our x values, we can see that it starts at 0 and goes on to infinity. But remember that 0 is not included. So you would want to use an open parentheses, 0, comma, infinity, or in an inequality form, it would be x greater than 0. Our range is going to be all real numbers because, as you can see, it's going to go up forever and down forever. So it'd be negative infinity to positive infinity. When we look at our second function, which was the transformation, the one that I graphed in orange, for our domain, we start at 2 and we go on to infinity. But remember that 2 is not included, so you would use open parentheses, 2 comma infinity, and in inequality form, that would be x greater than 2. My range is, again, going to be all real numbers because my graph is going to go up forever and down forever. So you could say negative infinity to positive infinity. All right, here we've got our functions as well as our graphs. My parent function is in pink here, and my transformed function is in orange. Recall that when we have something inside the parentheses as far as transformations go, this is going to tell us about a horizontal shift. Outside of the parentheses will tell us about a vertical shift. X minus 2 tells us we're moving to the right 1, 2 spaces. Plus 3 tells us we're moving up 1, 2, 3 places. So actually the transformations that we've covered before still apply with our logarithmic functions. Before we start example 2, I just wanted us to kind of refresh the fact that log base 10 of x is the same thing as just log of x. So log base 10 of x is our parent function that we graphed in the first example, and we found that it gave us a point at 10, 1. Log base 10 gave us a point at 10, 1. So what do we think one of our points is going to be if we have a base of 2? Let's explore. Okay, in example 2, we're going to compare log base 2 of x to negative log base 2 of x plus 3. So let's go ahead and plug our first function into the calculator and get some points so we can look at a graph. So to input a logarithmic function with a different base, you need to go to Math on your calculator and go all the way down to letter A, where it says log base. And it's going to let you have the option to input a base other than 10. So go ahead and plug in log base 2 of x. And then you're going to hit second graph. And remember, we're looking for that very first error. So our vertical asymptote is at x equals 0. We have a point at 1, 0, 2, 1, and 4, 2. So hopefully your graph looks similar to this. So I had a vertical asymptote at x equals 0. My first point was at 1, 0. My second point was at 2, 1. And then I also plotted 4, 2. Now let's go ahead and plug in our second function into the calculator and graph that so we can compare. We need to input our next function into the calculator. So it's a negative log, but we need to go back to math and go all the way down to A so we can add in that base of 2. So negative log base 2 of x, close parentheses, plus 3. Press second graph, and we're looking for the first error will tell us our vertical asymptote is at x equals 0. We have a point at 1, 3, 2, 2, and 4, 1. Your combined graphs should look something like this. We had, for our second function, we had points 1, 3, 2, 2, and 4, 1. And since we had the negative out in front of our log this time, our curve is going to go in sort of a negative slope direction. Our vertical asymptote is still x equals 0, but it's approaching that asymptote from a different direction this time. When we look at the first function that we graphed in pink, log base 2 of x, our domain is going to start at 0 and go on to infinity, but remember that 0 is not included. So you'd use open parentheses, 0, comma, infinity, and in inequality form, that's going to be x greater than 0. My range is, again, going to be all real numbers because, as you can see, it goes up and down forever. Whenever we're looking at the second function that we graphed in orange here, negative log base 2 of x plus 3, my domain is going to also start at 0 and go on to infinity, and my range is also still all real numbers. So the domain and range are actually the same for these two graphs. So when we look at our functions and compare them to the graphs, you can kind of see the transformations. The negative out front caused a flip over the x-axis, and our +3 had a vertical shift of 3. And if you recall what I mentioned before we started this example, when we had a base of 10 in our parent function, one of our points was 10, 1. Now we have a base of 2, so one of our points was 2, 1. That only applies to our parent functions. As you can see with the transformation, if there's any transformation taking place, it doesn't apply. So keep that in mind, and let's continue to our third example. In number 3, we're just asked to describe the transformations that would take place with this particular function. So let's first start with the fact that there's a negative out front, which would tell us that we're going to, the graph will be reflected across the x-axis. And then we have a 4 in front of our log here. That's going to be a stretch by 4, a vertical stretch by 4. We have a base of 5, but this is not going to affect our transformations. Inside of our parentheses, we have an x minus 3. So that tells us that we're going to move to the right 3 units. And lastly, we have a +1 outside of our parentheses. So that's going to shift us up 1 unit. In our last example, we're asked to identify the function for the given graphs here. And if you're given a multiple choice question, you can obviously just type in each answer choice until you get one that matches the graph. But here's a much easier, in my opinion, way to kind of figure it out. So let's look at this first one. And also, I didn't include it in the handout, but this second graph is actually a transformation of the first one. So let's start here. All right, I know that my vertical asymptote is at x equals 0. And if you've noticed with our previous examples, the only time your vertical asymptote is not x equals 0 is anytime you have a horizontal shift. So we know there's not going to be a horizontal shift, and that tells me that my x is going to be alone inside the parentheses, right? All right. So we also know that there's a positive slope. As my x increases, my y increases as well. So there's not going to be a negative out front. And now we need to figure out the base. So in our first example, we had a base of 10, and that gave us a point at 10, 1. In our second example, we had a base of 2, and that gave us a point at 2, 1. Now we have a point at 1, 2, 3, 4, 5, 6, 1, and that tells me that I have a base of 6. So that is my function for the first graph. So when we look at our second graph, as I mentioned, it's going to be a transformation from our first graph. So that tells us that we know it's going to have a base of 6. I'm going to go ahead and write that. Log base 6. All right, and now my vertical asymptote is at -5. So that tells me that there is a horizontal shift taking place. I've moved to the left 5 spaces. So inside my parentheses, I'm going to write x plus 5. All right, I also notice that my curve has my curve has kind of a negative slope now. As my x increases, my y is now decreasing. telling me that there's a negative out front. And lastly, the first point after my asymptote has moved from 1, 0 to -4, -2, it seems. So if I started at 0 for my y value and I moved down 2 spaces, this is going to have a -2, and that would be your final function. So as you're working through your homework and reviewing it and going through this, try to look out for those patterns. I think it does make things a little bit easier when you've done them a few times. When all else fails, the calculator is your friend. So good luck, you guys. I believe in you.